A rope with a tension of 15 newtons pulls two blocks with masses of 2 kilograms and 1 kilogram respectively over a smooth surface. Draw a free body diagram on the masses. So in this case here we got two masses, so that means we have to have two separate free body diagrams. So let's look at the 2 kilogram mass first. Well, as always, we have a force of gravity that acts down on each mass. Because this is on a surface, there's a normal force that acts up on it. Okay, now if we look at the other mass, 1 kilogram, we're not done with the 2, but we'll look at the 1. There is a force of gravity also on the 1 kilogram mass and a normal force on the 1 kilogram mass. Now, because they are attached by a rope, there's actually tension in the rope between the two. Now, the rope is pulling the 1 kilogram mass to the right, so we'll call this Ft. And the 2 kilogram mass is actually sort of being held back or pulled back by the rope, so there's a tension in the rope going backwards from the 2 kilogram mass. Now we also have an applied force of 15 newtons that acts on the 2 kilogram block, so we have this force out here. We can call this Fa, and we know that this is equal to 15 newtons. Now looking at both of these masses together, we can see that some forces cancel out, and that's going to help us with the next part when finding the acceleration. So Fg cancels with Fn. This Fg cancels with this Fn. These two tensions in the rope between the two masses cancel out with each other, and so we're basically left with a force applied of 15 newtons, which is going to represent our net force. Now for the next part, we're trying to find the acceleration of each block. Now it's important to note that because these masses are connected by a rope, they're going to accelerate together. So when we say each block, really we mean the acceleration of both masses together. So we know Newton's second law, net force is equal to mass times acceleration. And from our free body diagram on the previous slide, we know that the net force is 15 newtons because that is the only force that doesn't cancel out. It's whatever's left over. Equals the mass. Now we got to think about this for a second. Even though that 15 newtons is only directly acting on the 2 kilogram mass, it's also pulling the 1 kilogram mass as well. So really, this 15 newtons is pulling a total of 3 kilograms, causing it to accelerate. So as you can see, once we do the math, we find out that our acceleration is simply 5 meters per second squared. Now finally, for the last part, we want to know the tension on the rope that connects the two blocks. Now for this part, we have to ask ourselves, how much mass is this rope actually pulling? Well, it doesn't matter that there's a 2 kilogram mass in front of it. All that matters is what's behind it, and we can actually see that in our free body diagram. We're not looking at both masses now, we are only looking at the 1 kilogram mass. So in this particular case, the tension in the rope is our net force, and as we know, net force is equal to mass times acceleration. So to find that tension, Ft, we simply take the mass, 1 kilogram, and we know from the last part that our acceleration is 5 meters per second squared, so we simply multiply those two numbers, and we get a force of 5 newtons.